If I'm doing areas of shapes, this is very popular for the questions, then it's just going to be my length multiplied by my width. So the area would equal 4 plus root 6 times 7 minus root 6. Just like with our polynomials, now we need to FOIL. Multiply my first terms, multiplied by outside terms, inside terms, and my last terms. So my first terms are going to be 4 times 7. My outside terms are going to be 4 times negative root 6. My inside terms, root 6 times 7. And my last terms, root 6 and negative root 6. What is that going to give me? Well, I'm going to get 4 times 7 is 28. And then negative 4 root 6s. And then positive 7 root 6s. And positive root 6 and negative root 6, well, a positive times a negative is going to make a negative, and root 6 and root 6 is just going to make 6. And then I'm going to combine my like terms. I have the root 6 and root 6 can get combined. And my constant can get combined. So what am I left with? Well, 28 and negative 6 give me 22. And negative 4 and positive 7 gives me 3 root 6s. And that's what my area is. When I get to example B, these ones cause a lot of problems because I have 4 of the same side, which means that this is the same as the area is 2 root 18 minus root 27 squared. Often people will just square the first term and square the second term, but that is going to be wrong, right? This would still be 2 root 18 minus root 27 times 2 root 18 minus root 27. One of the other things I typically take into consideration is I like to deal with smaller numbers. I'm guessing you're the same as me, which means that anytime I see something like this, I'm going to simplify those radicals right away before I start multiplying it out, just to make my life a lot easier. So if I have 2 root 18, I'm going to simplify 2 root 18 to 6 root 2. I'm going to simplify the square root of 27 to 3 root 3. And then I'm dealing with much smaller numbers. You can still do it if you expand out this. Just look at to the same spot. It just means that you're going to have more simplifying you're going to have to do at the end. So I'm going to FOIL it. First terms, outside terms, inside terms, and last terms. And when I FOIL this out, it's going to give me 6 times 6 is 36. Root 2 times root 2 is bracket 2. It's going to cancel out those radicals. Negative 3 root 3 times 6 root 2 is negative 18 root 6. The other one, because it's squared, is the same process. It's going to be negative 18 root 6. Same multiplication happens twice when we're squaring. And then 3 root 3 times 3 root 3, well, the negative and negative makes it positive. And I'm just going to have 3 bracket 3. Sorry, not 3 bracket 3. 3 times 3 is 9. Sorry about that. When I multiply this out, I get 72. I can combine my two like terms in the middle, minus 36 root 6s, plus 27. And then I can combine my constants, or my non-radical terms, I should say. And I'm going to get 99 minus 36 root 6. Another really important thing for our next lesson is going to be multiplying conjugate binomials. Now, in case you didn't learn the term before, conjugate binomials means I have the same terms. In one case, they're subtracted, and in the other case, they're added. This is the factored form of a difference of squares. What happens when I multiply conjugates? Well, I can still FOIL it. And this is going to give me root 5 and root 5 is 5. Root 5 and root 2 is root 10. Negative root 2 and root 5 is negative root 10. And negative root 2 and positive root 2 is negative root 2 and root 2 just makes 2. And what happens? If I have conjugates, the two middle terms, so the outside terms multiplied and the inside terms multiplied, will be positive and negative versions of the same number, and they'll cancel each other out. Which means that all I'm left with is 5 minus 2, or 3. When I take a look at the second example here, same process. I'm going to multiply my first terms, and that's going to give me 4. 2 times 2 is 4, and root 7 gives me 7. Then I'm going to have negative 16 root 7s, positive 16 root 7s, and positive 8 and negative 8 make negative 64. And once again, with those conjugates, the two middle terms are the same, but with opposite signs, and they cancel each other out. And all I'm left with is 4 times 7 is 28 minus 64, or negative 36. So, what happens when you take the product of two conjugate binomials? Every single time, it eliminates the radicals. When I multiply by conjugates, there are no radicals left. This is going to be really important for the next two lessons. If I took a root b plus c root d and multiply it by a root b minus c root d, it's going to be a squared times b minus c squared times d, and I'm going to have no radical sign left. So, write a conjugate of each pair, then multiply them. The conjugate of this, if they're added together, is going to be subtracting them. 4 root 6 minus 3. What's that going to give me? It's going to give me the first term squared, 16 bracket 6, like we see here, minus the second term squared, 9. And the two middle multiplications, the outside terms and the inside terms, will cancel each other out. So negative 12 root 6 and positive 12 root 6 are going to be gone. So I can just say that it's going to be the first term squared minus, and the key is it's always going to be subtract, minus the second term squared. And what's that going to give me? It's going to give me 16 times 6 is going to be 96 minus 9, or 87. In the second case, I already have one negative and one positive. So if I'm doing the conjugates of this, negative 3 root 11 plus root 2, negative 3 root 11 minus root 2. In one case they're added, one case they're subtracted. Still going to be the same rule. I square the first one. 3 and 3 is 9. And root 11 and root 11 is just 11. Minus, when I square the second one, root 2 and root 2 is 2. 99 minus 2 gives me 97. The last one just adds variables, doesn't really change anything. If they're subtracted from each other, I'm going to do one where they're added to each other. I square the first term, so 5 and 5 is 25, and root x is just x, minus root y and root y is just y. And there's my answer. All right, go ahead, get some practice.